Hey guys, welcome back to my channel where we explore interesting math problems. Today, we'll be looking at a geometry problem with some ratios and polynomials incorporated into it. So the question reads, in the diagram shown below, BC equals 10. The length of AC is greater than the length of AB. Medians BF and CD are perpendicular. E is the centroid of triangle ABC, and EG equals 3. What is the length of AB? It might feel overwhelming at first with all this information, but let's start somewhere simple. Let's first analyze the triangle properties, since we are already given a right angle. Since CD is a straight line and angle BED is a right angle, then angle BEC must also be a right angle. And since angle BEC is broken up into two parts, let's label angle BEG with red and label angle GEC with green. And because angle BEC is a right angle, this means that the red and the green angle makes a 90 degrees. And since triangle BEG here is a right triangle, this means that the red angle would also make a 90 degrees with angle EBG. So EBG must be a green angle. Otherwise, it wouldn't make a 90 degrees with the red angle here. By the same logic, since triangle EGC is also a right triangle, angle ECG here must be a red angle. Our ability to figure out all these with just a few right angles is part of what makes geometry so fascinating. Now with the angles labeled with the two colors, we can see that triangle BEG over here and triangle EGC are similar. We can use this fact to solve for some side lengths by first letting BG be K. Then BG over 3 equals to 3 over GC. This is because the ratio of the leg with the green angle to the one with the red angle must be the same for the two similar triangles. Hence, we can know that BG over 3 is the same as 3 over GC. Now substituting in the variable K, we get this. GC is equal to 10 minus K because, remember, BC is equal to 10. So GC would be equal to BC minus BG. Multiplying both sides by 10 minus K, then by 3, and expanding it, then moving everything to one side, we get this nice polynomial equation here. Factoring it, we get 0 is equal to K minus 9 multiplied by K minus 1. To solve for K, we look at two cases. When K minus 9 is equal to 0, or when K minus 1 is equal to 0. Solving for the first case, we get K equals 9. Solving for the second case, we get K is equal to 1. Although both solutions work when you plug it back into the original equation here, the actual solution is K equals to 1. This is because the problem explicitly stated that the length of AC is greater than length AB. If we let K equals to 9, then length AC would not be greater than length AB, so we have to take the value of 1. While it might be a little hard to know this in the early stage of problem solving, another approach is to look at the diagram as a visual aid to help you. If you do choose the wrong value, however, all you have to do is switch the values of AC with AB, because switching between whether K is equal to 1 or 9 merely switches the length of AC and AB. For the sake of concision, I won't explain why here, but you can look at how we solve this problem along with the triangle properties to deduce why. Okay, So now we can label this part BG with 1 and GC with 9. Since triangle BEG and EGC are right triangles, we can solve for even more side length using the Pythagorean theorem. So for triangle BEG, BE squared is equal to BG squared plus GE squared. Plugging in the known values, simplifying, and taking the square root, we get that BE is equal to the square root of 10. So we can label that here on the diagram. For triangle GEC, we can similarly set up this equation. EC squared is equal to EG squared plus GC squared. Plugging in the known values, simplifying, taking the square root, and further simplifying, we get that EC is equal to 3 multiplied by the square root of 10. And we can also add that to the diagram. And because it was said previously that CD is a median of triangle ABC, which just means that it cuts the length of AB in half, and that point E is the centroid of triangle ABC, we can apply the property that EC is twice of DE. Just as a side note, if you're curious about the proof of this property, refer to the links down below to understand why. So since EC is twice of DE, we can take half of EC and label here that ED is 3 multiplied by the square root of 10 over 2. Now we can set up another equation for triangle BED since it's also a right triangle. Substituting in the known values and simplifying, taking the square root, and further simplifying, we get that BD is equal to the square root of 130 over 2. And we can also add that to our diagram. Okay, so now we have all these side lengths labeled on our diagram. We can finally solve for length AB. And because remember, CD is a median of our triangle ABC, meaning that it bisects or cuts AB in half, we can set up the equation that AB is equal to twice of DB. Substituting in the known values, we get that AB is the square root of 130. So that's our answer. A tiny challenge for those of you watching is, can you figure out the length of AC? Share your solutions in the comments down below. Okay, that's it everyone. Thanks for watching and we'll see you next time.